All right, hopefully as you can see with today's video, we're going to keep building on that background knowledge that we're developing. You've been solving some pretty complex equations, but now we're going to step it up just a notch, and we're going to solve equations with variables on both sides. So it's kind of important to remember that our goal was to isolate the variable on one side of the equation, and now we're going to encounter a situation where we'll have variables on both sides of the equation. And so if our goal is to get the variable by itself on one side of the equation, obviously what we need to do if we have variables on both sides is to get them on one side. And so what we need to remember is variables stand for unknown numbers, and so the rules that apply to numbers when we're solving equations also apply to variables. If I want to get rid of a variable, I can either add or subtract to move that variable term. If it's a positive variable term, I'll subtract it. If it's a negative variable term, I'll add it. I'm going to use inverse operations, and I'm going to do that first. First things first, I got to get all the variables on one side of the equation. That's top priority. Use an inverse operation, then remember whatever you do to one side, we must do to the other. You'll do a little combining like terms, and you should be good to go. So let me give you a few examples to kind of spark that memory. Here we have a situation where we have 5n minus 2 equals 3n plus 2. So we kind of remember in our background, all right, it looks like we maybe have to do some simplifying on the right side with the distributive property. So I have 5n minus 2. I distribute this 3 to each term, and I have 3n plus 6. Now that I see that I have variables on both sides, I'm thinking, I want to get them on one side of the equation. I need to get rid of this 3n. To get rid of 3n, I'm going to just subtract 3n, because we know that 3n minus 3n is 0, and that'll go away. But our rule of algebra says whatever we do to one side, we have to do the other in order to keep each of those sides of the equation equal. So now it's just a matter of combining like terms and simplifying. And when I see that 3n minus 3n cancels out, I'm just left with a pretty basic two-step equation that you do know how to solve now. I'd have 2n equals 8. And I divide by 2 on both sides, and n equals 4. If we ever have any questions on, well, did this work, did I do it okay or not, we know that we can go back into our original equation and check our answer. Good example to start, just because I think you see the math advice and the life advice that I have for you. Make sure you stay positive. What I mean by that, I have 8y plus 4 equals 11y minus 17. It's up to us on what we do. I could subtract 11y on both sides and work from there. But when I see that, I know that that would give me a negative 3y, and we know that sometimes when we have negatives, it causes some errors. So rather than subtract 11y on both sides, I'll subtract 8y on both sides. I'll get rid of the 8y instead of the 11y. Again, I have to do the same thing on both sides. This cancels out, and I'm left with 4 equals 3y minus 17. Just doing a little simplifying and combining like terms. Trying to get the variable by itself, so I'm going to use the cover-up method. I'm going to add 17 to both sides. I'm left with 21 equals 3y. My last step, use the inverse operation of multiplication, which is division, and I have y equals 7. A couple examples to kind of use your background knowledge of what we talked about with fractions and everything else. I don't like working with fractions. I want to get rid of them. We said to multiply everything by the least common denominator of the fractions. I see a 5 and I see a 10. That makes me think that the least common denominator would be 10. Notice I'm multiplying everything on both sides by 10. 10, when it multiplied by a over 5, the 5 and the 10 could do a little cross canceling. We end up with 2a minus 3, the 10s cancel out, notice, equals a. And then don't forget that I have to multiply 2 by 10, so this would be a plus 20. I can explain this a little more over the discussion board or in class if we have a few questions, but that's the basic idea. Top priority when we have variables on both sides is to get them on one side. So I have to get rid of this variable on the right side first. That's top priority. Notice 2a minus a just gives me 1a minus 3, which equals 20. And now we're left with a pretty straightforward equation to solve. If I add 3 to both sides, a would equal 23. So what was a pretty complex equation, at least to start looking, if I look at it, it looked pretty complex, and it turns out it's not so bad. Last two examples, an important note to keep in mind, something we've talked about in the past, but I wanted to remind us. I see I have the distributive property problem here, so I'm going to take care of that first. I'm going to simplify 5 times 2x and 5 times 1. That gives me 10x plus 5, which equals 10x. And then again, we said if you have variables on both sides, first thing we do is get them on one side. Subtract 10x on the right, subtract 10x on the left. Everybody sees on the right that 10x minus 10x is 0, so I have equals 0. And then sometimes kids want to say, well, 10x minus 10x, and I still magically have an x or something like that. I don't. 10x minus 10x is 0. We know this. 0 plus 5 is 5. And we're left with a situation where 5 equals 0. I'm going to leave you hanging on that for a second. We'll do another example, and then we'll have a pretty important conversation at the end here. Second example on this page, 6x plus 2 equals 2 times 3x plus 1. A little simplifying to do on the right side, use the distributive property, and I get 6x plus 2 equals 6x plus 2. You might see something happening here, but I'm not going to let you off the hook just yet. If we have variables on both sides, we've got to get them on one side. So I subtract 6x and I subtract 6x. Notice that leaves me with 2 on the left, and it leaves me with 2 on the right. So we have two very different situations here when we look at these problems. On the top problem, our variables canceled out, and we were left with 5 equals 0, which I would say is a false statement. That's not true. I don't think 5 equals 0. If it does, I'd like to trade money with you. At the second equation, I have 2 equals 2, which is true. And so that leads us to the last thing I want you to get in your notes by watching this video. Remember, when solving equations, if I cancel out my variables and I'm left with an obviously false statement, that means there is no solution to the equation. There's nothing that we could substitute into that variable that would work. On the other hand, if I get my variables to cancel out and I'm left with an obviously true statement, that means that all real numbers are solutions to the equation. Anything possible would work. Any real number could be substituted into that variable and give us a true statement. Go back and look at this then. Notice I have 10x plus 5 equals 10x. There is no number that we can put in that's the same thing when you add 5 as when you don't. So this situation, we would actually say no solution, or if you remember it all from your background knowledge, we could also say it's the empty set. There's no number in that set that would work. On the bottom, however, 2 equals 2. Any number that we put in there is going to work because I'm going to multiply it by 6 and I'm going to add a 2 to the left. I'm going to multiply it by 6 and I'm going to add a 2 on the right. Obviously, if we had the same number to begin with, we're still going to have the same number at the end. This situation here would be where we would say x equals all real numbers. That kind of wraps up solving equations with variables on both sides. Remember, top priority is to get the variables on one side of the equation, and remember, variables stand for unknown numbers, so the same rules that we've always used still work in this situation. Have this video watched and have notes ready to go by class on Tuesday.